You're alive. Okay. Um, all right, guys. So we're going to go over the engineering report of the collapsed building in Miami, and I am just opening the report. Let me see if it will allow me to share my screen. Okay. Okay, it doesn't allow me to share my screen. I will be very helpful to be able to share the screen. But okay, so let's just go over this report. Let me should be able to share my screen. Okay, so it's not allowing me to share my screen, so I'm gonna go ahead and just go over the report. So this is a report. You know, this large building, this high-rise building collapsed in Miami about a week ago, and there has been over 10 confirmed deaths, and I believe over 150 is still missing and unaccounted for. So potentially over 100, fatalities, and of course people have been under a lot of stress and lost lives and lost properties. So it has been a very, unexpected tragedy for a high-rise building to collapse in a major metro area in the United States. So the question is, what happened? Everybody is asking the question, what happened? Why did this building collapse? And to find that out, I'm going to go over some of the findings of the engineering report that was prepared about 3 years ago. This document is dated October the 8th, 2018. So it's a little less than 3 years ago. And the document was prepared by Morabito Consultants. They go by MC as the abbreviation. And so Morabito Consultants, the engineering firm based in Maryland, and they did an assessment, a structural assessment of this building in 2018. The report was issued. I'm assuming the work was also done in 2018. So a little bit about this building. This was a high-rise condominium building. So it was a residential building. Of course, hundreds of people lived in that building. Um, and it was a concrete structure. So here's the key. It was a concrete structure, and it was a high-rise concrete building in a highly populated area in Miami, Florida. And the building was collapsed. If you have seen the photos of that collapse, it's very scary the way this building just comes down. What you would see if you look carefully, it's really what you expect in the collapse of a structure, like larger structure. It's what's called in the geologic domino effect, which means that some part of the structure collapses, and then that creates an excessive, increased stress and force in some other part of the structure, and so the failure is extended to another area. Now that that second area is pretty much collapsing, the next area, the area next to it, is now being overwhelmed by stresses and the impact of that damaged area. So that kind of domino effect, the damage starts from one corner and it goes all over to pretty much until the entire structure is collapsed. So that domino effect kind of in the failure of a building like a high-rise concrete structure is pretty normal, which means that it doesn't have to be all too unsafe for the entire building for it to collapse. Even if one area of the building is overwhelmed and somehow is damaged and there's an impact, that failure can extend and go to other areas, and that entire building can collapse because of that domino effect. So all it takes for a high-rise building to collapse is one area, not two small area, collapse and fail. And we're going to go over this report to see what is the likely cause of that failure in that high-rise building, and what is the likely scenario that other buildings could similarly fail. So what are the things that we learned from this experiments? We do a lot of inspections. We do a lot of inspections of residential and commercial buildings, and this is also a lesson for us, understanding the consequences of uh, ignoring the evidence. And the evidence was there. What I love about this is a very sad story. But I'm so excited is that there's actually a document. There's actually an engineering report that actually brought major concerns to the attention of the people who own the building. So I'm glad that the engineering community or the engineering representatives did their job right. If you look at the report, it's very clear from the report that this incident could have been prevented. And this is my opinion, that this could have been prevented because the issues that are discussed in this report are very clearly, uh, to the scale that could be used to explain the cause of this incident. Okay, so I have went over this report, couple of times, and I could just tell you from my understanding, this is pretty obvious. The problem that caused this collapse was was almost certainly related to the corrosion of rebars in the concrete. So what does that mean? That means, okay, this is a humid area. Miami is a beach. There is close access to water, and of course, it's oxygen is in the air. So water and oxygen make a concrete structure always vulnerable to rebar corrosion. So that's the main phenomena. That's the main uh, process or concept under which the concrete structure could lose its integrity, could lose its capability to carry loads, and could collapse. So, what is uh, what is the problem that you're specifically talking about? So when the concrete structure has rebars in it, and of course it has some gravel, some and then some cement. So in this, among these, items, so we got the sand, the gravel, we got the cement, and then we have rebar. Rebar is the one that is most vulnerable to the presence of oxygen and moisture. So what happens is, of course, it's iron, it's a steel, it starts corrosion. When moisture is present, that corrosion is accelerated. When corrosion keeps happening, the rebars start to expand. A rebar, a corroded rebar in a concrete can expand up to 7 times its original volume. 7 times its original volume. Imagine if you have a rebar in a concrete, and because when moisture and oxygen penetrates, and that happens when the concrete quality is not great, or it's really so available, so moisture and oxygen is so available, meaning that it's a humid area, and somehow there is not perfect uh, collection water collection system, and somehow oxygen, of course oxygen is there, but moisture is being able to penetrate into concrete. That could happen when the concrete cover of rebars is too small, it wasn't constructed right, or somehow the concrete quality was not, there was high permeability of concrete, so moisture is able to reach to rebars. So when the rebars are going to start corroding, and when they start corroding, they start uh, growing volume up to 7 times its original volume. So that means the concrete is going to start to crack, because concrete cannot take tension. We know that from our undergrad studies, that when you concrete is under compression, they perform great, but when they're under tension, they will crack, and they can't take tension. It's very low tensile capacity of concrete as a material, as a masonry material. So this is the problem with all masonry materials. So uh, when the rebars start to corrode, they expand and they cause cracks in the concrete, and that means there's a separation between the rebar and the concrete. So the concrete is no longer uh, uh, attached to the rebars. The rebars and the are no longer working as a system. They're not working together to carry loads. So the structure is compromised. The structure is compromised. And when that happens in a larger scale, and that's what you see in this report, you see in this report, there are several photos, a lot of photos in different areas, on columns, on beams, on fascia, on balconies, on different areas. There is evidence. You could already see the exposed corroded rebars in multiple areas, in several areas of the. So the rebars are corroding, and then what's happening next is, of course, when you have this compromised structure, when the rebars are corroded, and so thus they're expanding in volume, and thus there's cracks in the concrete. So sometimes the concrete cover just pops out, and you can see the rebar. So the topping, the layer of concrete that is covering the rebar is completely popped out, and it's no longer even part of the structure. Then you have the rebars that are separated from the rest of the structure, which means that they're no longer contributing in load bearing capacity. So now the structure is going to be not capable of carrying the same loads it was capable when the structure was engineered and when it was originally built. So the structure is going to start to deform. It's going to start to have large deformation. And you can see in the report, there are several photos showing, for example, several balconies, there are tiles that are completely deformed. There are tiles that are cracked. There are other parts of the structure where there is large deformation. So and it's you see, I wish I could share my screen. I'm seeing next time we should use a better tool to do video, but I'm looking at these photos, and there's clearly corroded rebars on concrete, structural components of this building, where the concrete is completely gone, exposed rebars are completely corroded. So, and then we have deformation. So here you go. So we got all the items that we need. We would even know beforehand, even before we do the inspection, that this is Miami. There's humidity, and of course there's oxygen in the air. So it's a vulnerable area. Now in this structure there is corrosion, significant level of corrosion. There is evidence that the corrosion is to a point where there's of concrete with the rebars, and the concrete basically cover of the rebars is completely popped out, and therefore we could tell that the structure is no longer capable to carry the loads. And then there is deformation. There is cracked tiles. There's other issues that show there has been the structure is now underperforming. So it's not even able to carry service loads. Remember, when we are talking about design of a building, we have the service loads, and then we have the extreme design loads. So for example, the day-to-day loads are the loads that are just the dead load, the weight of the structure, and the live load. People expected to be walking, and the stuff, the furniture, anything is in the building on a day-to-day basis. That's the service loads. And then we have the extreme loads when there's a strong hurricane, when there's a extreme event happening in the area, which would cause a significant increase in the loads the structure is carrying. Now, when you see the structure is already having large deformations in a normal day, on a regular, I guess, basis, on a very permanent basis, then you could already say the structure is already underperforming, so it's not even capable of carrying a service load. So what does that tell you? First of all, when we talk about the corrosion, it's an ongoing process, right? So because there's so rebars in that concrete, and I know when one part of the rebars start to corrode, rebar is this it's it's all connected to a large network of rebars in the concrete, so it keeps going. So the rebar corrosion is in process, and it keeps going until pretty much the entire structure completely deteriorated, and the concrete is completely incapable of carrying really any structural load. So the corrosion is ongoing. Then we have the situation where the structure has deformed, and because of that deformation, now we have additional stresses on the structure. When we talk about design of buildings, is a very hard assignment in the design of buildings that the displacements are going to be small. This is what we do when we engineer buildings for pretty much for the residential, commercial, for based on what the service loads are carrying and all that. So the structure starts to have large deformations. Now we are having additional loads. We have the P delta effect. When you have deflections, now that additional bending moment on the structure. So when you have the structure, now the arm of load, so you get a center of load, every load, you have the central load, when you just the equivalent load or equivalent location of the weight. So we have that center is now moved, and then you have an arm because of that displacement times the weight of the structure. Now we have a bending moment. So there's going to be an acceleration of that deterioration and the damage in the structure. So we have corrosion that is ongoing. Then we have the P delta effect, which is causing additional forces in the structure after its initial displacement, its large displacement, and then of course there could be accidental loads that could occur. The accidental loads could be because of any soil settlement, any sort of underground water activity. It could be because of some winds that are stronger than the winds they would have on a very calm day, normal day. So sort of new events that are still technically within design loads, but they are beyond the normal day-to-day loads of the building, could trigger. Now the structure is not able to carry the design loads, so it's definitely under performing because of the corroded rebars, because of the damages, and then because of the increased loading, because of the P delta effect. And then you can have all these random environmental loads like wind pressure, like underground water activity, like soil settlement, that would trigger, and the structure can no longer take it, and then domino effect. In some part, in some area of the structure, some column, some beam is now very overwhelmed, no longer able to carry the original loads, the original design loads, being under additional stresses because of the P delta effect, because of the deformations, and then some environmental triggering event, such as a stronger wind than the usual, and or other groundwater activity or anything else that would just trigger. Now that area of the structure is going to fail, and the moment that area of the structure fails, you get the domino effect. So that the next structural component is now being overwhelmed because there used to be another component next to it who was contributing on load bearing, but now that other component has failed. So now this other component cannot carry the load. So this is gonna fail. Now you get the next one. So very quickly the domino effect, your entire structure is gonna fail. And to me, this could have been prevented because it's obvious from all these reports, from all these photos and the discussions in this report, that the structure was undergoing major corrosion problem, rebar corrosion problem. So, so my summary from this review of this report is that this could have been prevented. It was mostly related to corrosion in the rebars. You could see these photos. I'm going to go ahead and share this link to this report at the bottom of the post we have on LinkedIn, so you could go over the report and you can see the photos. And I just want to use this opportunity to highlight that this could happen to any other building. When we see those symptoms, the great thing about this phenomenon is that it doesn't happen overnight. You're going to see the symptoms in time, and you're going to have well more than enough time to see those symptoms and even take action. They don't happen suddenly. It takes years before such incident can lead to a collapse of this scale. So I would say it was negligence by people who operated the building and saw the report, which was issued 3 years before the incident, and the report is very clear that there was major concerns about the performance of the building. Fortunately, no action was taken early enough, and now we're seeing this tragedy. And so for any other structure, I would say it's definitely very important to keep our eyes open. Look at the symptoms. These are obvious indications that something is going on. When you see rebars exposed, when you see concrete cover of a rebar is completely popped out, and you see the rebar underneath, when you see that in several different areas of the building, that's the time to report, that's follow up, and that's the time to take action before something happens like what happened in Miami. Thank you very much, guys, and I'm happy to take any feedbacks, any comments. If you guys wanted to discuss it in any chat below the video that we'll be posting online, I'm happy to engage in any sort of discussions about this video. I'm open. That's my opinion. I have a lot of experience in concrete rebar, and I really feel like it's so obvious where it all started and how it could be prevented. Thank you, and have a great day.